So I think I've spoken enough on this particular slide. Let's move on. But when you go to the cloud, the storage architectures, particularly for the databases, are becoming different than what you might have gotten used to in the data center. And the failures could happen in multiple ways. Failures could happen because people are deploying more and more using DevOps mechanisms, or for maintenance reasons, people deploy, and those deployments could cause a problem. Data corruption could happen in the backend or the storage system. So, maybe because simple human error. Ransomware attacks happen, they continue to increase. And also zone outages, not necessarily the entire region outages that are very rare, but zone specific outages could happen as well. And also, if you have architected your application kind of in a distributed way, individual service outages could happen. It could be that your database service, goes offline a little bit, whereas your application services might continue to run, or the platform services could continue to run, or even the management of the operation services could go down. So for any reason, the service disruptions could happen. So in that case, what is the way to kind of control this? What is the way to architect your application infrastructure on the cloud, and how do you really kind of balance between the cloud cost? Cloud cost is as a problem. And also, it's organizations that have moved to the cloud are reining in the cost equation, because people kind of spin up those wonderful instances really easily, and then try to control afterwards, putting some kind of a governance and so on. And now, for the resiliency purposes, if you have to really increase the number of nodes, or even put some kind of an additional zone or additional region, then the cost also increases. So you will have to really balance between the two. And that also means that you will have to look at your SLA requirements. I mean, is it really necessary for you to increase the number of instances, or double the number of instances, just because you need to decrease the RPO times, or you have to increase the recovery times quickly, which means that you will have to have enough instances of the same type. So it is always kind of a balance between the financial liability for the company, which means that comes with the cost. And cost is a big deal given our COVID-19 situation, particularly now. On the other hand, you have the application SLAs. And specifically, you were comfortable with your application SLAs. You had kind of a nice agreement between the business and the infrastructure teams, and the businesses were happy to an extent. Now you're lifting and shifting your workloads over to the cloud, and you will have to really rethink about that application SLAs, especially when you run on a shared public cloud infrastructure. So it's a cost. I cannot simply say that, increase application SLA. So it depends on your application, specific application, and business that is satisfied with that particular SLA. So when you try to achieve high availability for your database-based application, let's assume that it's a simple 3-tier or type of application. Typical situation is that in the data center, you will have a SAN infrastructure. It could be fiber channel SAN or iSCSI-based one. You need to architect in such a way that you have the shared storage with a cluster server that is having some kind of a heartbeat to make sure that the nodes are running properly. But your shared storage is the common thing. The layout of the storage is such an important component in the high availability architecture, because when the nodes shift, and when the nodes, one side of the nodes die, the clustering software will automatically shift the front-end component, including the databases, operating system, and so on, over to another node. I'm talking about a very simple cluster systems in the data center, nothing complex. You could complicate all of these pictures in multiple nodes and quorum corresponding to every one of the clustering software, and how quorums are maintained, and so on. So in a simplistic sense, organizations architect high availability system using clustering software. Now, the situation is that when you shift those clustered applications, clustered database bound applications over to the cloud-based architecture, the first thing that you will come across is that the storage infrastructure is so different, because you allocate storage appropriately. You request, you get the storage, that's beautiful. But how do you really mimic that clustered architectures? And that's one of the reasons why people really go to high available database architectures provided by the cloud service provider themselves. You could obviously architect and re-architect in such a way that you could put an always-on a SQL Server type of architecture. That is one way to do at the server level. And then the storage is again separate. The layout is different, and you will have to really think about the availability component of that. So cloud-based database architectures really take care of that problem underneath by really architecting the storage system or re-architecting that storage system, and depending on the cloud service provider. And we had seen the previous picture of looking at how Google has architected with a regional persistent disk with a synchronous replication between two different storage volumes underneath. And we don't know exactly how they have architected. All we really care about is that when you configure some kind of a regional disk, you will get the availability of that disk. Then you configure your database configurations appropriately. If you look at the RDS, this particular picture comes from AWS for their Aurora system. Now you could see how they have architected. Again, this particular picture is a very simplistic look of their infrastructure based on their blogs and so on. But you could look at how the reads and writes are split appropriately, and the configurations are given to the customer, and then you can take advantage of that. But now, how do you really achieve your application resilience? At the end of the day, that is all fine when the storage architectures change. So let's revisit back the little bit and then think about how that completely alters the view of the application resilience itself. So in the data center, you think about storage, then you think about the data services where you snapshot, replicate, and clone depending on your scenarios. And then you buy a bunch of backup and recovery and DR systems together. You somehow make it work. If you could really test those systems consistently, every quarter, every month is too much, but every quarter at least, or every 6 months, you somehow get to that point. What people really forget is that there is a parallel infrastructure that's about networking, and a lot of these backup and vendors that have really supplied this vertical and this data services and backup and recovery and so on, they never worried about the networking component of it. But when you go to the cloud, the networking is software defined, which means that you can flex that networking based on your needs, which means that you should be able to combine that with your backup and recovery systems. And that is an understanding. Now, if you go and make use of the highly available database services that are available directly from the cloud provider, you might go to those database services for many reasons. And also you could potentially architect one of those systems as a self-managed databases as well. So in both cases, this particular conceptual diagram is applicable. And then if you're really pushing the boundaries, you could let your developers containerize those applications, and you can potentially run them on the Kubernetes type of platforms. That is all great, but now you'll have to really think about how will you get your application resilience in order, right? It is not going to be just a backup and recovery. This is all infrastructure speak, if you will. Similar to how you tend to think less about individual virtual machines, the networking component of it. You don't have to really upgrade your networking equipment with the latest firmware and operating system on top of that. You'll have to really think about other ways of dealing with it, right? So application resilience is changing. That's when you realize that what are the top 10 risks for your application resilience. So yes, I understand that my requirement is that I need to have a highly available architecture, and I need to be able to do that. And guess what? I kind of brought in the old backup provider that provides a little bit of resiliency when things really go bad. Maybe every 12 hours, or I back up every hour. But what happens to my database logs and things like that? And then what happens to my HA architecture? And what happens to my backup? And what happens in a DR category? And then you'll have to think about all other components. And I don't want to just walk through one by one. Let me just put all of these different components, and particularly with respect to storage lifecycle, with respect to locking in the your proprietary application data in another data management system. You cannot imagine how vendors are pulling the data out of your production systems and creating some kind of a parallel secondary storage environment in the name of data management. And then you will end up managing the storage life cycle for the data management itself. In the end, it is all creating another kind of a lock-in mechanism. Then when you go to the cloud, the default operation mechanism is an infrastructure as code. People are still not writing enough infrastructure as code to make it consistent. You'll have to think about continuously improving your infrastructure. Otherwise, you might end up treating the cloud infrastructure just like another data center, which is the worst case scenario, which goes to Gartner's argument that if you're not really taking advantage of the cloud infrastructure fully, then your application availability will suffer eventually, right? So make use of those capabilities that are already available. Now, I didn't really stress upon this particular fact that ransomware attacks are increasing day by day. We are not hit until we are hit. So which means that, all we have to get hit is one time, and that, puts a different perspective on our entire application and entire application architecture and the infrastructure and so on. So you will have to really think about what happens in that particular case. What happens to my application resiliency when a ransomware hit happens? And with all of that, when I ask our potential customers, do you think you have coverage for your application environment? Do you think your applications are really protected? And that's when they say, I pretty much get silence on the other end. It's pretty hard. It's pretty hard is that it's 10x work in any angle that you think about. That is a big risk. And this is a webinar, so I'm going to be as neutral as possible, but I will have to put this concept to new audience to start thinking about, should you really rethink your application resiliency? Should you really think about the backup and restores? That's separate. Then storage-based snapshots. And those snapshots wouldn't have a clue about application environments, obviously. And then you will have to really think about all the recovery systems. And when you have multiple storage vendors supplying all kinds of storage systems, what happens is that you don't have a mechanism to really control those individual storage system replications. Then you will have to think about a host-based replication system like vSphere replication and so on. And then what happens when you have that kind of a system working for some applications or a component of the application? Now the developers are looking to go to containers. Gosh, let me at least gather my breath here. Let me think about the situation, and then CFO is pushing me to go to the cloud because there is a clear I wouldn't say light at the end of the tunnel. I would say the dark end of the tunnel where in the data center is going away. Now I have to really think about how the cloud is going to really behave in all of these situations. And that's why a lot of risk happens. At least you could think of the resiliency component. If I could simply let somebody else take care of the resiliency. I could take care of the production environment. And we made it very simple. We made it to a point where you can subscribe, add the policies, and Appranix will take care of your application environment. I know it sounds crazy enough to see that, hey, I change my application environment, I change, and I tried protecting my application, but one of the administrators, cloud operation team members went and changed the firewall. And the security group was changed yesterday. I had no clue, and the application stopped working. There was a new deployment, because of which I had to redeploy some of the component infrastructure on the cloud. I had to change my VPC configuration. The routes have changed a little bit, and the auto scaling really spun up. And what happens is that I will have to really think about how that's going to be protected. Right? In those situations, what happens to your application resiliency? And our signature statement is that you can pretty much onboard, protect, failover, or recover. I'm taking these two use cases separately, and we are going to talk about failover-based HA configuration in this particular webinar. I will show you an interesting demo of how you could really put together an architecture and you shift your workloads over to the cloud, no problem. Architect in a way you like it, the way you think it's going to run your production environment, and we'll take care of the rest. That is the idea of application resiliency. Don't have to think about individual backup and recovery of individual systems. You don't have to really think about the replication management between your primary region and the secondary region. And also, you don't have to really think about the infrastructure as code, and also the dependencies between those infrastructure components that really make up your application environment itself. And what happens to your load balancer configurations? What happens to associated connectivity between those load balancer configurations? In those cases, how do you build an application environment time machine? Right? That is backended with infrastructure as code. What if we said that that is already built? You don't have to worry about it. You go ahead and change your application infrastructure the way you like it, through cloud consoles, through CLIs, through API, through third-party management systems, through any means that you think is right for you to change your production environment. You could be at peace thinking that if there is a system to take care of the application resiliency, of course, you don't have to really think about all the backup. Of course, backup needs to happen. I should be able to back up my infrastructure and the data every hour, every 15 minutes. Sometimes I have configured the system to be HA. If a database is replicating asynchronously from one region to another region, how do I really bring back that application again? And that is the pertinent question that we will answer. And we also say that go ahead and test it as many times as you like. This is one of the critical pieces that we are encouraging people to do on the cloud platforms. And we do not encourage this type of complex scenarios in the data center. We are simply assuming that you have moved to the cloud. We are a cloud native company. Our systems run on the cloud. Our systems utilize our own services to provide 99.9% SLAs to our customers. And we run this test time and again. In fact, we have automated those tests using our own system. And we are encouraging people to use that application resiliency. We call it as application resiliency simulation. You don't have to worry about the time. You don't have to worry about the complexity. Cost is an equation that you will have to really balance yourself. But even there, if you're running a test for a couple of hours, it's worth it, because the liability for your system, liability for your company, the reputation of your company is paramount compared to the cost that you might incur in the case of a resiliency situation. And you don't have to obviously worry about the skills shortage, because the system automatically does all the work for you. So all you have to do is to simply put a policy so that Appranix runs those resiliency simulations. So given that, a number of companies have gone and used our system, this is a financial services company that have really benefited huge number of instances. In fact, some of their instances are like 146 application load balances with 76 RDS instances in the back end, with front-end components of the application running across multiple VMs. In some applications, 25 VMs running the front end of the applications, right? So number of companies have really taken advantage of them. And if you think about it, under the hood is very, very simple. You subscribe from the marketplace to your environment is read-only access. We do not take data from your environment. Your application data stays within your project, within your account. We do not touch them. We don't even know them. All we take is metadata of your application environment. The system automatically builds an application environment. Time machine, it continues to learn, adapt to your production environment. So if you change your firewalls, we automatically capture it. So unlike the legacy backup systems, you can recover your firewall, you can recover your load balances, you can recover network configurations along with your data, right? And we will show you how you could really build that. If you're a DevOps shop, you could pretty much build that capability into your DevOps pipeline as well. It could be applicable for some organizations, may not be applicable for everyone, right? And also you could push beyond one region. And in fact, in some cases, you could let some managed provider to retain a copy of your data so that, that's all, we call it a level 3 resiliency. So that is all possible on the cloud. The question is, are you really taking advantage of it, right? So multiple use cases, but I'm going to give you a demo that's very, very interesting. This demo consists of distributed components, right? A component of the application, very distributed, that is running on the containers. And you could substitute those containers with a bunch of virtual machines that you might have lifted and shifted from your data center over to the cloud. That's totally fine. And those application front-end components, we assume that they are stateless, because most of the time you deploy stateless components in the front end. Then you might have stateful platform components that might be running in an application environment. And the critical piece is that the database configuration should be having zero data loss. That's the key thing here. It's a high availability scenario where your database is capturing your application data continuously and replicating that to another region for your protection, just in case. In this particular case, we have a MongoDB platform that's capturing the catalog of the application that we are going to show. So we chose kind of a e-commerce retail application, which is familiar for a lot of our folks when we demo that kind of an application. That also, when you add the carts, multiple people are adding and buying the e-commerce items, and the application is getting stressed, which means that the loss of application availability directly impacts the organization. So that's kind of a nice application that we have. And we are using Google Cloud to demonstrate this particular webinar demo. You could pretty much do that on the AWS as well. We will support Azure pretty shortly this year as well. Next a month or so, we will release a preview for cloud application resilience for Azure platform. Now, in this particular example, the primary instance is Cloud SQL based. You could replace with any other database instances that is replicating. That's totally fine. And the front end, as I mentioned, is running the containers on Kubernetes platform. So we are using GKE out of the US Central region. Then a couple of instances running MongoDB platform that stores catalogs of the items. And in this particular case, tone socks, if you will, right? It's we made it interesting. And that is the global load balancer that is getting connected, and that allows the application backend to distribute automatically and scale depending on the need. And the setup allows the data to be kind of completely copied every time it's asynchronous, which means that it gets copied immediately over to the next one, which means that you have zero data loss. But this particular configuration is not talking about how do you really fail over to the other region if the primary region fails. Now, when I click the button, right, everything else will automatically fail over. Before that, what we are going to do is to initiate some kind of a disaster on the production side so that the application instances will disappear. And Kubernetes will automatically kind of shrink. It doesn't have to completely go away. And the primary region will lose the connectivity to the global load balancer, which means that clients will not have access to your application. Now, we'll have to bring the entire system back again, which means that we'll have to make sure that replica is shifted to be or promoted to be the master data, which means that all the data are intact, but the instance has to make sure that the data is visible to the application. And the primary instance is gone now, right, from the central region. And the MongoDB will be brought up automatically, depending on the RPO that you have chosen. So for MongoDB, we have chosen 1 hour RPO. For Cloud SQL, it's 0 data loss, 0 RPO problem. And then the issue is that how do you really bring back your application really, really quickly, which means that the entire RTO failover is very, very crucial. And then you grow your Kubernetes. Kubernetes in this particular case is automated, where when you deploy more and more components, it automatically grows, which means that your system has to be reestablished in terms of connectivity to the global load balancer so that clients will have access to it. So that's the overall demo here. Let's make it happen. So in this particular demo, let me show you, a few screens so that you don't get confused, because it's a complex application that we wanted to demo here. The application itself is called Weave Socks, where you can go and buy socks, tone socks. And if you look at the catalog, it's this kind of socks. So you can add more and more. I'm logged in as Govind here, so you'll see more items. What we are going to do, we are going to automate adding tone socks into my application cart. That way, it kind of simulates many users adding items in the shopping cart. That way, we will be able to demonstrate how you can bring back the entire shopping cart as if nothing happened in the other region of the cloud. Now, the backend, the databases, the catalog databases are running sock shop databases and things like that. Those are catalog databases that are running the MongoDB. And then you have the Kubernetes nodes that are running. And if you look at the Cloud SQL instance, this has the critical data necessary to retain the shopping cart. People are buying every second, maybe every second, hundreds of items. So those data will be asynchronously, replicated to the replica instance running in the second region of the cloud. That is continuing to happen right now. And you will see the front-end components are running the containers on a Kubernetes platform. So we hosted that particular set of components on the GKE platform. So you have the central region running the production A, and the production Z is the failover to the East Coast region. So that, if you look at it here, there is nothing here. So there is only the warm Kubernetes cluster without any application components, because we want to fail over this application really, really fast so that your users do not feel the pain of losing their shopping cart items. You cannot afford to lose this application. Mission critical, company is losing money, and that is a situation that's happening. So what we will do, we will induce a disaster, or induce a failure in the system. So let me connect to the Cloud Shell, where I will execute a situation where the disaster happens. Before that, what we'll do is that we'll add the socks appropriately. For that, we'll automate it. what we will do is that we'll decrease the speed a little bit. This is an test automation system. When I click on this particular one, it's going to continue to add the items in the shopping cart. So let's see what happens there. So let's run the system here, and you will see the shopping cart items increasing really, really quickly. So it will continue to add 3 items, 4 items, and no matter what, it will just continue to kind of push more items into the shopping cart. So you'll see now it's 4, 5. It's completely automated. I don't have to even waste time to add more and more items. This is simulating what typically thousands and thousands of customers. To an extent, we are simulating it, right? So this is while this system is adding the shopping cart items, obviously Cloud SQL is replicating those into the read replica, which means that all the shopping cart items should be intact, right? So there are 13 items. By the time we induce the failure, it could be like 20 items or so. So what we are going to do, we are going to induce that failure right now. So here, make sure that I go to the right place. There is a disaster script, so I'm going to just induce a disaster right now. And what will happen is that the services will go away. And also to give you an idea graphically, the production A environment looks like this, right? There are so many distributed components that are running. You'll see those services slowly disappearing. So let's look at the production Kubernetes environment. Let's turn off that production environment. Slowly what will happen is you see the pods are disappearing, which means that the pods will not run the containers. When you don't run the containers, obviously the application will go down. So when I refresh, the application is totally down. We don't even know how many cart items have been captured. Now we are in a panic mode, meaning that I lost my application. I need to fail over. This is where Appranix helps. Appranix is a cloud application resilience system. We will skip the component of how you can subscribe to Appranix. There are multiple videos available on our YouTube channel. You can very easily go to AWS Marketplace, type Appranix, and you subscribe. And we promise over the coffee break onboarding, which literally is, and it has been proven across many different potential and real customers as well. People say nice things, so thank you for all of them having experienced that wonderful experience of onboarding. It's all about user experience. It's not about technology anymore. It's like, I don't care about the infrastructure. I don't care about the cloud infrastructure, but just run my applications. And I continue to focus on running the production systems and what happens in the backend. So we have discovered the production A cluster. It has namespaces that is running the shop application, which is the application that I described here. It is described as a nice assembly. Assembly you can think of as a combination of infrastructure, cloud infrastructure components put together, right? And that assembly consists of the front-end containers running in the Kubernetes cluster, and also an external assembly. That assembly consists of, if you look at the resources, that assembly consists of two instances running MongoDB, and a Cloud SQL that is configured as HA Cloud SQL, so that the application is replicating all the data. For demo purposes, I have slowed down. Otherwise, I would have kicked off the recovery really, really quickly. So what we will do, in fact, the application is down now. So what we have to initiate is a failover. So let's go to the timeline. As I mentioned, application resilience system, Appranix application resilience system captures an application environment dimension. So you could go to an action and do a failover here. So we are going to failover. We're going to choose the prod Z cluster in the recovery region. The recovery region is running on the East Coast of the cloud. So we'll initiate that, and the recovery has started. And in the back end of the platform, you'll see the recovery has been initiated for the external assembly as well that consists of many of these components. And the component assembly has Cloud SQL. It will automatically switch the Cloud SQL or promote the Cloud SQL from the master to the read replica, and read replica will become the master. And other instances will be recovered per the RPO that was configured in the policy. It's a combination of that policy here, retention-wise. I'm not going to go into the recovery simulation. That is not the idea of this particular demo. So now what's happening is that a bunch of things are happening in the backend on the cloud platform itself. So if you think about it, the instances that are being scheduled are being recovered in a couple of places. So we will watch out for the production Z area of the Kubernetes, that will come in here. That is not completely fully populated yet. On the other hand, you will see an on-demand recovery has been initiated. What that means is that the backend configurations are shifting to a different region. Apprenix has written the entire infrastructure as code automatically. If you look at it, the system wrote this many lines of infrastructure as code, cloud native infrastructure as code. So you could do AWS complete cloud formation will be automatically written at a particular point in time. You do not have to worry about the dependencies, or you don't have to really learn anything about cloud formation. You don't have to really learn anything about deployment manager, which is the native infrastructure as code for GCP, and the dependencies of those configurations, right? So as I mentioned before, let me revisit that particular slide here. All the dependencies, right? All these dependencies are automatically figured out which one is supposed to start first. We automatically figure that out. Which one needs to be populated really, really quickly. So even if your applications are running across multiple zones, Appranix will figure out those zones and then shift the load balancer appropriately to the second region and figure out the number of zones are available in a different region. Sometimes, in a particular region, one zone might be available. 3 zones might be available. In the Virginia region, you have 6 zones for AWS. When you go to Oregon, you have only 3 zones. So, do we have to really keep track of all of this? Why not let an Appranix type of system take care of worrying about the availability of those infrastructure, and also, the type of instances. There are like more than 60 different types of instances that are available in one of the region of AWS. Similar is the case with GCP or Azure for that matter. So they keep releasing these newer and newer instance types as the time goes on. 5 years ago, we had only like 10 different instance types. Now it's 60. 5 years down the line, who knows how many instance types will be available. And when you make use of them in the production, because you want to run your applications highly performant or based on production SLA requirements, now when you fail over to another region, are you supposed to worry about those? Because the region may not even have the right instance types. In that case, do I supposed to keep track of what's happening in the second region of the cloud? Right? What is my storage configuration? What is my RPO? What's my RTO of bringing all of that? My application is dead right now, right? Company is not making money. The SLAs are down the drain. My only worry at the moment is that I should be able to bring back my application. And what is really needed for that, I don't have to worry about all this infrastructure as code. All of the components that are necessary for me to bring back my application. Infrastructure itself, if you look at the resiliency, oops, there is some kind of an internet connection here. No, it's my own local problem. No, and the recovery is complete. Hopefully, You're able to see all of that. Looks like I have run into some internet issues, but it's back. So if you look at the recovery itself, recovery is complete. The back end of the recovery is complete, which means that if you go back to the demo that we configured, all these backend compute and Cloud SQL should be complete. Let's see if Cloud SQL came back and the system is promoted. The read replica has been promoted to be the master. So now it's promoted, is all equal. So this is might be running, we don't care, but the Cloud SQL replica is running. And also, let's see if the backend infrastructure for the container applications have come back. Yes, they are all running now. The original configuration on the region, we induced the disaster, we induced the failure it back. Now we have to make sure that application itself is running again. Let's refresh it and see if the application is back or not. The application is back. It's connecting back to the load balancer and so on. Let's refresh it just to make sure that the application comes back completely. And login. And see how many items in the cart. So there were about 19 items that were added. We started with 0. We kicked off an automation to continuously add the items in the shopping cart. And there is no RPO problem with respect to the important database that was supposed to bring back. And the other catalog items, they are not changing. We use MongoDB for storing all these SOX images and all the catalogs and stuff like that. But the important thing is, my shopping cart is intact. The user, as a user, I do not see a problem other than like, it came back in about under 6 minutes to be precise, even though the application is very, very complex in terms of multiple components. One is all the front-end components running in the SOX shop assembly. So if you look at the assembly itself, you have many resources, and the backend is running on the database, and that has many different instances. You don't have to do anything. In fact, adding these instances are also very, very easy with respect to resources. It automatically calculates the dependencies. So let me stop here. Hopefully that was useful. We had a little bit of hiccup with respect to the initial sharing of the screen. We have recorded the entire webinar, so I will post it on the YouTube. I will make sure that you get all the recorded information as well. Let me stop here and see if there are questions. Any questions from the audience? I know we gave you a lot of information in a very short period of time. I hope that was useful with respect to kind of giving you an idea of application resiliency. And obviously, you do not have to worry about the backup or any of the infrastructure. So here, there are wonderful questions, looks like. What failure attacks do you support? Obviously, so thank you for that question, Dukesh. We support multiple failure attacks. I mean, it doesn't matter what really triggered the failure in the production environment. You can simply assume that there is a service that is really, taking care of the resiliency in the backend, right? And that's very, very key. Because you could be changing anything. The failure could come from a ransomware attack. Failure could come from a developer working late night and he deployed it unknowingly. There is human beings make all kinds of mistakes, just like I do, right? So failure could come from anywhere. The only component that is important is that how fast can you recover your system. And not everyone knows how the system is actually put together as well, right? So we take care of multiple ways of, we don't really worry about how the attack really came in, right? Failure came in. All you can do is click that button, recover it. And then you borrow time so that you can really go and debug who really induced that failure, what was the reason why the failure really happened, and so on. Another question is, do you have an on-prem solution for resiliency engineering? Unfortunately, no. But having said that, if you're running Kubernetes-based stateless components on-prem, we do support that for the stateless component of the containers. You can do a DR. It is a DR component, not a HA, because HA involves real-time databases replicating the data, right? And that is, we can only do it on the cloud platform. So what we encourage is that when you move to the cloud, think about dropping a lot of this technical debt on the backup, recovery, HA, DR, all of that. This is all infrastructure speak, right? And that has to be a better system. And assume that we have one of those systems. Do you provide SaaS-only consultation services? We pride ourselves to be a solution provider, a SaaS provider that literally, you can onboard your own solution. We obviously support you. We can dial into any number of calls that you want in terms of making sure that you are successful. So there is no additional cost, by the way, because if we made the system so easy to use, we don't have to supply those resources to make sure that you onboard really quickly. And, verbatim statements. One of the customers dialed in, and then, he was just adding the policies and he hit the button to recover. And we asked him, JP, did you happen to read our documentation? And luckily, I had our UX designer on the call, and we are really proud of him and the entire team that has put together the system. JP said, I did not read the documentation. So we believe that the system is, the user experience is the key, right? We will not allow even adding one more button to the system unless it's absolutely necessary. So that is how we control it. It's almost like an iPhone experience. The customer experience matters, not the technology. Customer experience really matters. So do you provide SaaS-only consultation? We do provide consultation. If you please let Mike know. Mike has provided his email address. If you do not know, it is mike.rothstein, ROTHSTEIN @appranix.com. You can find him on LinkedIn and many other places. So we are available. Please give us a call if necessary. We are all available to help you in terms of onboarding your application. At present, I'm evaluating Gremlin. Do you have a comparison data sheet that I can refer for? I would say Gremlin is a chaos engineering solution, meaning that you knowingly induce a failure. We are actually complementary to Gremlin in the sense that you induce a failure, who is going to recover your system? Gremlin is not going to recover your system, right? Failure could come from anywhere. So go ahead and evaluate Gremlin. But the topic of the discussion is not about inducing the failure and how you can recover it from a production point of view. As production will continue to go on or go through multiple changes, that's totally fine. We are talking about recovery, right? How do you really reliably recover your systems, your data, and continue to kind of back up that environment, including the data? So if you want to recover one particular instance, go ahead and recover one particular instance, just like any other backup recovery system. Go ahead and do a DR test using our system. Go ahead and do a HA failover of your entire environment after a failure. You can get it back, right? So that is totally fine. And does Resilience support cross-platforms? With respect to the container-based components, yes, we do. In fact, one of our customers is getting SOC 2 compliance using our system by doing a DR between GCP and AWS for the container-based component of the system. With respect to the database components, as you know, data gravity is super important, which means that you cannot really easily move from one cloud platform database to another cloud platform database. So that is a complex issue that we do not attempt to solve, but you can always shift from one region to another region. You can obtain your SOC 2 compliance with that. And the SOC 2 compliance is, for compliance reasons, that is one time, maybe a couple of times in your lifetime. But on the other hand, think about real life failures. Think about using your system multiple times. So cross-platform for front-end components that are running on the containers, particularly in the Kubernetes. We don't care which Kubernetes environment you run. We can DR your Kubernetes containers, all of them, over to another cloud. But please make sure that environment connects back to your failover within the same cloud provider, different region, assuming that your production system went down, right, completely. So we help you kind of place your environments and the data to a different region of the cloud easily, and as easy as clicking that button that I showed you before. Okay. All right. Any other question? I know I ran over this particular webinar by 2 minutes. I really apologize. I hope this was useful. If you have any more questions, please do not hesitate. We are here to help you out. Okay. And really appreciate the time. Thank you very much.